Hello? Cool. Today is going to be a relatively short stream. Um, I'll be doing my grad class homework and looking at AI stuff. What would this be used for? That's my question. Like, let's say for capstone, my next semester studio, if I'm working with a site and working with a model, like, I want the specifics. Even if this can provide specifics, it's going to be in mesh form, and that's going to be so much harder to work with than NURBS. I don't know. I guess I should learn some more, like, why does this matter? And if it's Gaussian splats, it's only going to be from one viewpoint that you get an accurately detailed map. I don't know. I really don't see a use case for it. Okay.
As it looks. Welcome to the Beam Tutorials. This is a three-part series of tutorials introducing Beam, online spreadsheet visualization for estimating carbon impact projects. Beam is developed by Focus. Part 1, the Beam tutorial. So the first thing you're going to notice about this is it looks like a pretty fancy version. They've done an awful lot of work here to create something that doesn't look much like a spreadsheet. And one of the things they've added, even though your top menu here looks pretty much the same as the sheet menu. If you look over here, you'll see what they've added. And click on that menu, you see that you've got a lot of options here in terms of your project, saving a project, building a project, and stuff. The other thing I've done is using the sheet menu is I've gone and made a copy of the sheet that they gave me access to. So I'm not messing with it. It's called a query that you go here, you'll see a bunch of tabs here on the bottom. Most of them have locks on them. There's parts of the sheet that are locked and can't change. Those are typically from your calculation tools. And again, strongly recommend that you use your guide. But we'll go ahead and start click on the project here. This is going to be your first page. Now, you've got an input legend, and you can see here the units we're going to be using are imperial units. That's going to be count units, common units, and so and this is up here on the Beam menu where you can use metric. And there's different colors here for cells. This kind of light green cell is material that's required to say the progress. And then this kind of light, we call it kind of light blue green color. These are cells that are used for the material calculation, so that's where you input into them. And beams are used to provide carbon emission for that particular material. And then finally, we've got this dark blue color, which we call central. And then white cells are the cells that are calculated based on this. We'll go ahead and here, project name, we'll call this simple. Something like that. We're not going to fill out any of the stuff, etc. Say Beam is available as a free tool. Do use it for the company, we can fill that one out. So we can take 6, building type, fill that one out. So just lots of stuff. So we're going to do a single detached house. Construction type, let's go ahead and say construction. This is a lot of the project type, so it's pre-designed. What else we need to know? Stories about grade. So the project we're doing is actually 2 stories above grade, but I think I just want to do it first. Yeah, so that's 2 stories above grade. Total floor area is going to be up 1200 square feet. Let's go ahead and check this. So walk over here to the sketch model. So this is a sketch model of this Spira. We talked about in best practice with the Spira model. This model is built with the interior out, exterior wall review. It's only the interior that you can it's going to work just fine for this. There's going to be some slight differences in the thickness of the wall between the surface area of the interior wall and the exterior wall. Some differences with the but we're not going to so first thing I'm going to do is check actual square footage. Group things together. So we've got about 500 square feet. Now, the nice thing about having big model quotes, big model quote, sketch out well, is that you can easily pull the quote up. And then the other thing that's in here is we want to know how much a wall is. And so I've actually already got that for the top story of the apartment. And that's about 900 square feet. Put it click on the open shift together. We're looking for group that might be selecting this as well tonight. And we're coming up here on our box with about 1,000 square feet. And that's enough larger than the top, but in fact, we're looking for group to be selected. And then 1,000. Okay, and Windows Center, I think about so not a whole lot more. It is actually add the actual structure, whereas a whole lot more of that effectively. So go ahead and roughly subtract that. I got about 970 square feet the wall, and it's all 30 square feet for the upper floor, floor, I've got about just about 960 square feet peg wall, and we'll I'm going to go down here, check how much roof area I have, and this is actually interior ceiling then, but I need to know that as well, and that's going to be about 660. And the actual roof area is not a whole lot different than that. We'll do it later on. Third part will be the same problem. Alright, so if we jump back down to so like that, and scroll down to you're looking at this project actually making half of the so we're going to see now. So without this much work to start with, it's putting on pad. So a lot of things that are might be considered here's big use of high performance thermal control layers like a double step wall system or continuous exterior insulation are built right into it. So all those things that might be hard to find on something that's geared more towards minimum construction are built right into the project. So we're going to look here, and we're going to ignore actually all this foundation stuff. So all we want to do is just get a really rough idea of what's going on. That's going to really skew our numbers because most of the carbon impact is, a lot of the carbon impact is probably going to be in the concrete. So at least initially we're leaving out the concrete. Anyway, so what do we have? Exterior wall area, so we're going to go ahead and put that in, and this is going to be for total, I believe, yeah, two-story place. And so total floor area, actually, when we finish filling this out, so our total floor area is going to be 960 plus 970. So let's go ahead and use calculator here. Well, actually, we don't even need to do that. The great thing about this being a spreadsheet is we can just use a spreadsheet function, right? So we're equal, and we go 960 for the second floor plus 970 for the ground floor. If we hit enter, it automatically pulls it up, which is great. Above grade conditioned area is going to be the same, 1930, and below grade conditioned area, we're going to assume this is slab on grade rather than conditioned crawl space. Okay, great. Now, if we go down here, we can enter some of these others. Again, not worry about these other dimensions right now. We're thinking about slab on grade though, so we can go ahead and put in the slab area because that doesn't require any knowledge what these guys are. So that's going to be our wall. Oh, no, this is floor area. See, I screwed this one up, didn't I? I'm putting my wall area and my floor area. So my floor area is actually going to be 586. Really, it's 600 because that's the actual exterior area. So same thing, 600 plus 600, so it's 1200. So you get that. I made a mistake putting in the wall area rather than the floor area because I just been looking at the floor area. I'm going to enter the wall area later. So our above there again, that's 1200. Okay. So again, foundation slab area, that's going to be 600. Okay. Foundation wall area, that would be for a stem wall or a basement wall. We're playing slab on grade construction, so we don't need to fill that out. Slab on grade will have a continuous footing. Pretty easy to figure out what that one is. So well, let's go ahead and see if we can get that too. So we go here to this fire model and click to enter it again. What we do is just double click that and raise the center, and we get a length. So that's 108 feet. Near enough. So we're going to go back to being. There we go. Now I use a Mac, so my the interface I have for SketchUp and Sapphire may look different than when you have Windows, and my web browser may look a little bit different than Windows as well. But the Beam tool shouldn't look any different since it's completely web-based. All right, so here footing going, so we got 108. We have 108 running feet, and then the height of our footing. I'm going to try out an idea called that I talked about in one of the other lectures called frost protected shallow foundation. This means that the height of our footing is actually a whole lot less than it would normally be. So our footing is only 14 inches below grade, and for the climate where it was built, frost line's actually 30 inches. And what we did is we used some insulation over the slab to prevent cold air from getting into the ground over the slab and freezing. So we effectively raised the frost line to near the surface, which let us get away with this shallow frost protected foundation. And then the width of the footing is actually tapered, so we can take the average width, which is going to be 14 inches. Okay. So that's all been input there. All right. We got our slab. Oh, and of course, yes, I did enter it in there. I want to make sure I'm not screwing up the home. This is the garage. That looks good. Okay, foundation wall area again. Not using foundation walls, not using pads or piers, which is maybe the kind of construction you would use if you want to slope. Exterior wall area, and that's where I can put in numbers on its head. So again, equals 970 for the ground floor plus 960 for the second floor. There we go. Our window area. Now my total window area in looks like I've got 30 on the ground floor, so we'll just go ahead and let the spreadsheet do that. So 30 plus 101, and there's that. Party. Well, party wall would be if we were doing apartments. That's saying we wanted to calculate just the carbon impact of a single apartment. But that apartment is going to have a wall that touches another wall. Or if we were in a slot building, kind of on Main Street or Greenfield type building, we also might have the walls. Because we do not in this project. Interior wall area, there really should be a difference between interior wall and exterior wall. There's not going to be mathematics, so we're just at this stage. So we're just going to throw that into frame floor area. We do have a second floor here, so our frame floor is going to be 586. It's actually a bit smaller than the exterior. Finished ceiling area, we've already pulled that number off, and I believe that's 660 square foot. Roof insulation area, as it says in the comment, that's going to be typically the same as the ceiling area. Okay, now we've got the roof surface area. Now that's technically that's going to be a little bit different. Let's go ahead and just see if we can calculate how much different that would be. So that's an easy way to do this. Maybe is grab a tape measure tool. There we go. I happen to know that the walls in the structure I'm planning on walls being about a foot thick, and we'll go there. Oops. Pull off that. There we go. Okay, so that should give me basically the outlines of what I need, and then it's a 12-12 pitch, and so that's about 17 feet there. So we're going to go up, and we'll go up by should be about 8.5. Oops, 8.5 feet, not inches. There we go. And that means we should pretty easily be able to draw our roof more or less, just like that. And quickly just drag that solid over. And so this is really, and that's roughly accurate. I mean, there's a few other details in there, and I'll just click on that real quick. And so that makes quite a difference. That's 941 square foot of roof area rather than 900 or 660. So, and I'm gonna go ahead and just delete that since I'm doing it. Right. So if we go back here, now we're gonna put in our roof surface area, and that's 940 round. Timber frame volume. We're not using heavy timber in this. No post something like that. Garage. We're going to do this again as if this has a garage. It's the entire thing. Heavy timber in this, no posts, no beams, nothing like that. Garage, we're going to do this again as if this has a garage. It's the entire thing is living space. And I think that's it for the project page. So now, and that's all your basic information there. Go over here to footing the slabs, and open that up. You'll see it takes a second for it to populate. And you'll notice that we've got some numbers in here. So it's assuming, actually, some numbers for the slab and some other stuff. And in some cases, we've got some the emissions due to that material is showing up here. In other cases, those numbers aren't going to be there yet because we haven't pulled it. So here we have our footings. Note that it's already from the information we've entered. The tool has already done a takeoff on a number of yards. So our footings we're going to use 2,500 to 3,000 psi standard mix for North America. Some other options here if we went with some fly ash and slag or some other mixtures. We can start dropping that number on the carbon emissions quite a bit. A lot of places, those mixtures may not be available from the local batch. So we're just going to use the average here. So we check that. It tells AIM that that's what we want to use. We've got no columns, footings, or pads. Here's our slab. Now I had already entered on another project. I'd already entered 4 inches, which is why that was there. But notice we can change that. And as we put the thickness of the slab in, go back to 4 since that's a standard slab thickness. These numbers change. Again, we're going to use 2,500 to 3,000, just like that. Let's check. And so we go on that guy. This gives you a lot of different options. Again, earthen floors, probably not the thing that you're going to see as an option on something oriented more towards construction. Now, rebar for continuous footing. The steel reinforcing bar in US sizes, we're going to use number 4 bar. That's half-inch bar, and it wants to know how many feet. So our length on that is going to be 2 bars. Should be fine, and that's 2 bars, and we're just going to say it's basically 2 times the quantity. And here, this is interesting. Yep, looks like, maybe not. So we're just going to do that math by hand. It's 216. There we go. There's our feet, and we're going to use this number 4 bar. Like that. That's not a whole lot of carbon. Column swing tabs, not using that. Steel reinforcing bar, no. Our reinforcing mesh for the slab, there's not going to be a size associated with that. It's just going to be square footage, so that has already been checked. Helical piers, we're not using. Subslab insulation. Now, even if it wasn't required by code, we would want to insulate the slab underneath concrete if you're doing slab upgrade. You're going to lose an awful lot of heat to the slab otherwise. And then subslab insulation is also a huge part of the frost protection shallow insulation, shallow foundation system. So again, I've already selected the EPS foam board. I've already selected this Suprema XPS. That's a 3 psi board, and this is a board that's available in states that require greenhouse gas reduction in the blowing agent for extruded polystyrene, as opposed to the expanded polystyrene. And Washington State is one of them. This is the material I actually used. It's really good material. Pick that, and you'll notice that look at these numbers here. This is really about the lowest possible number you can get. It's even better than EPS board, even better than Type 1 EPS, which is the lightest, flimsiest board you can get. So for plastic foam, this is about as good as it gets. It's a little expensive, so you're going to pay a premium if you try to use it on the entire building, but it works great on this side. And there's some other choices here. Some of these are potentially really interesting products. From glass board, the cork board, you notice none of them are really available from U.S. manufacturers, which means that if you want to use it, you're basically buying from Europe and European sources. And if you take a look, the foam glass board actually doesn't save you in carbon emissions versus plastic emissions. Even the foam glass aggregate, which is like a gravel, is still only about a third of what the of what the XPS is that we're looking at. So really, this is about one of the best options. This is better than mineral wool, actually, which is often thought of as being a lower carbon material than plastic foam. Okay, basement flooring, not doing anything with that. We're going to assume that our slab is just going to be something like maybe an acid etched or an acid stained concrete that we're going to put a nice wax coating over the top of. So we're just going to use concrete as concrete. If we wanted to do tile or something like that, that's in there. Note that bamboo flooring, if you see these negative numbers here, those are actual carbon sequestering materials. All right, crushed stone, we need an aggregate base. Already entered that, 6 inches of aggregate base. That's a compacted stone that we're using underneath the foundation material. Anything else? No, pretty good. Go to foundation walls. We're not using foundation wall in this system. Go to structural elements. So this is going to be steel structure, heavy timber. We're using light frame construction, so nothing to enter there. If we go to our exterior walls, you'll see that we've got some choices. We've got light steel. We're not using light steel. We're going to do just a pretty standard site built stick frame. Framing spaces. We can do something at least part way to an advanced framing system.
I'm not doing these notes. I was talking to other people. They said they weren't doing the notes either because it's not like it's really not required based on the announcement. Let me just reread this. Like, the assignment, the professor doesn't care about this class. Look. It was due the 9th. He didn't even release it until... What was Monday? 13, 12... 11, 10th. He didn't even... It was due the 9th. He didn't even release it till the 10th. Like... What do you mean? These were technically assigned the week before? Sure, okay, I'm fine with that. But if you're not gonna fix a deadline that I know you've gotten emails about because I've emailed you... like... I think... Okay, I must have emailed him about a separate thing, but... I know he's gotten emails about this. There's no way he hasn't. And it's like... In addition, remaining lessons have been unlocked. This week's lesson includes video content related to the use of the Beam tool. The discussion assignment should be used for peer-to-peer discussion of the lecture content and final project. I've added a TA. Hold on. Like, half the class isn't gonna do this. What?
System. So rather than 16 inches on center, we're going to use 24 inches on center, and we're going to use 2x6 lumber here. And I'll go ahead and check that box. And here's our use TI, so
I'll watch it in 4 times speed. Get through the rest of this video in 7 minutes. Get through the other videos and... What would that be? 3 times speed would be 30 minutes. 4 times speed would be like 20.
But if that cost credit or anything, what I don't see here is analog as which is technology has integrated related error. Also probably going to use and then the other possibility is design board. Because if you're going on one board, use it diagonally, and all the way doing things, and it costs a lot later, a lot more than enough to speed, but it really is part. And the calculation, again, or sorry, that's what we're looking at. Calculation is 20 wall, because we're calling let's say we're looking at calculation. And so we look at putting our plane lower options. This is going to give us whatever it takes to fit us whatever get our plane for this area of wall. These are the conditions. Now, I said that we can't get our insulation into a wall. If we went there, you'll like it. We actually could. That's almost smart. We could actually get like R or 5 inches out of a wall. But notice that our wall current condition is just and value that in accurate reflection of the amount of money that goes into production of aerial. And so it is like trades like how it's insane, both hard perspective and from money. You see that these spray foams, the industrial body spray foams, are also really used here in certain applications. Open cell starts the other day, all of those all pretty nasty stuff in terms of the sheet insulation, not bad. Also, we got numbers for about half of the spray foam. Normal that. Okay, then actually, that's in there around some of those elements. And that basically the process of making normal, as we talked about with different pullers, involves heating up and essentially melting off and turning it into a hot so takes fuel and fuel. So mineral wood cell and fiberglass is standard. A little bit of normal glass and melt at lower temperature. Fiberglass app, this is standard app insulation that's used by all the time. This
I don't care.
much nicer in terms of carbon emissions. And I've worked with materials that have nearly the amount of emissions that standard fiberglass filter. Then we move into some of the new materials, and all of these out here are going to actually carbon. So and fiber, I think the materials are unlikely most of them, most of these items are going to be sensitive to the material or later required to salt material. Or we're going to do this with one second. So we can look at cycles of lasers are bad, that's sequesters out the same amount. It moves about the same amount of carbon as a standard fiberglass app protein. Wood fiber is like it's sequestering so it's sequestering almost like 2,000 kilograms of CO2 for all the cycle. Look here, here's the problem with all this stuff is none of this stuff is material, which means 1 times expensive material and difficult to find. Similar sense to concrete, that's probably that in labor costs or just difficult to find somebody using material in a program that way in a lot of applications. Straw popular material, really big question again, this looks like it's manufactured material. But all that is really stuff here. One thing about cellulose is also is round up, newspaper, and cardboard. Easy to find, you have it as big box retailers, and these numbers are pretty good. We're just going to use generic, standard, intact, or intact, a little lighter install, it does a job, and you'll just have a practical. And that basically just not as good better actually than some of these wood fiber installations and how to do them. Okay, and finally, team installation. Now, we're trying to do this installation on the exterior. We said we're going to do R10, two layer. I'm probably going to actually line up with R1 and exterior outer line, and we'll do EDS on board here rather than more sensitive CS. And see that the particle material is really hard, not too bad. So we're just going to imagine here and take a look and see. Let's say we use half material, so two layer R10 outer line, and then we're going to spring 40 outer line stuff. And what else is again is essentially type 1 EDS, our frequency curve, same as the right, so we're going to we're not doing CT walls, we're not doing CT walls, we're not doing fill, like that. And that's all those we just all those things are actually building this tool. Sit built in, defense running, you got a lot of options, a lot of different walls. Okay. Use something else. Here's strapping point now. This we do with the so strapping spacing on the front space is an horizontal vertical at the same time. So we're going to go ahead and strapping the concern. There we go. And in the product, I use a little more. I'm going to go and I'm using photo reasons. There we are. So that's how go. So what I'm going to do, you see, I've chosen double lays wood frame in fact. There's another option there too. So let's go ahead and see that it is. So that's like a nice Anderson wood color. This is similar to the glass. And we also have those different ways. Notice that when we go to blades, we're going to front blades actually higher than a lot of the double ones. The triple blades can be sometimes very good ones. And maybe a couple of items in the graph. That's nice. It's important maybe working on the interior walls, not really specifying the interior walls, I think it's okay. And then floors, it's used for building, so we do have some more in here. That's what it was. We got 90 interior and 1954 interior items, okay? So ideally, we're going to use 9 high-dose spacing, actually 16 inches on center. And this is part of the cases versus using framing. Now, framing lumber, we were using 60 by 10, 50 by 12, I guess that's 50 by 12. So there we're at 103 versus high-dose, which is a little better. Problem with on the floors is it's cheaper. It does have a lower carbon emission, which is really hard to certain. So it's going to be extra labor involved. Probably using expensive all the color out of boards. And it's going to be hard to build those. So I really like using the PDR, the lights. So for got choice between plywood, speed, and definitely super range. Plywood, 52, 57, probably nice product. Yours is cheaper, but this is a floor. It's going to take more materials. Pretty boring too. Again, great in terms of carbon emission, but it's pretty limited. So floor underlayment seems to be for top. Yeah, for itself, you go ahead and use Edge Vision. I'm not sure. This is a different software. It's not actually. I just use it. We're using a little more per wood. But it's not a whole lot difference with across these hardwoods. It's mainly about the refinish, hard not refinish. You're not technically at a seat, but you can see the ratio. We'll cut from the bar that the guy has on it. That's pretty good. And it's really and about bamboo, technically the hard spring, but it's a tough one. Look at the insulation there. We're actually explaining the Edge Vision on that. It's a little tricky to get cellulose into a horizontal surface. We need to do that hard glass. And we need to touch. I think that. Okay, so that was like, so you actually cost a little bit. If we did go ahead and go cellulose, we actually scrap it. That's not going to go back. So steel finish can be 5 travel, often required, certain for doing this and so we check that. And then roof framing, we're actually using a truss. Now here, the case of the truss is 4-12 pitch, even 12 pitch, which is really quite different. The whole difference between different framing systems and site builds is about lattice, they were later. It's not like so go ahead and just take truss anyway, and figure the difference between a 12 pitch, which does use material versus shallow, is not really. Okay, now roof decking is 12 feet, that's 5 feet, so you plywood, not a lot of there. When you're framing, roof, roof strapping, not putting a mixture on insulation roof, when you're roof. Roofing, we're just using a standard asphalt shingles, just project because of the shape of lot and height building. Most of that's not usable, so it just makes sense to use something that might have a really nice segment of metal roof panels versus asphalt shingles. Then you can see that actually the carbon emission steel versus asphalt, pretty steel, that's very steel. All right, and we actually use steel after we get that all the way down to 7.3. Every tile smoke, I'm bringing that everybody same day. Roof cavity insulation, and what we did for roof cavity insulation for here is rather than against that, we pretty different roof system. Because we essentially, we're actually pushing on the roof against that on 6 12 pitch, block wood, so we are 10 to do it. We did that in both work, that's not too bad. Roof fiber again, and every all the indications we're going to do material. There we go, and say we use that. So that should be everything that we do. So this is down there, and we're going to we're doing basic information here. That's probably not too much. I'm doing the interior walls here. We haven't included some other stuff. Mostly it's same thing as garage. We're going to do interior walls. We will not have anything like the plans. So here's our for most of the and that they all later tennis. You know, right at the edge you can do it, so not too bad. And then also this down here the highest part material. And so you see that most of our carbon is on the sides, so it's surprised that it is those floors to the So the last step, in final part 3 of these I'm going to go through basically the same project as more details to the walls. We're going to play around this is kind of right now. I really say, okay, I'm just going to show you what happens if what happens if I say I'm on the side and I can just run over here. So what happens if I go over here? I do that's as we probably do from last time. We'll work on this forward, that's anyway. And so we're going to find it, how much it's going to cost, probably don't know. So we'll save this kind of optimization for last. We're not putting on crush stone, anything like that. We do check locally and maybe our construction aggregate, if we got some available companies who are better at bring them on the website. We definitely do something like that. So this is about 1957, so let's imagine that we're able to get a mix with quite a fly outside. And so we managed to when they do design, on the first lab, it's like, you know what, this is all interior, it's going to be behind. We really don't need, I think that's concrete, flying code, everything else, and so there. And then we save another 100 programs. Yeah. I'm not regret that, because I'm putting it on if additional things, those. The exterior wall is the only place where we can changes. And what we changes is to make another change frame from another isn't good. We can go plywood instead of OSB, hardly anything. So, ground insulation, we're going to pre-break with the impact soils. Really didn't buff the number unless we're going to go with something like a cast based or something. But again, you're going to run trouble with one or inch wall, we're probably have our in others, definitely running trouble, especially in small areas with set running side, things that are using to what we can do is continuous insulation. You can see there. If mineral wall is not using good versus EFS. Vacuum insulated panels, get out, and again, when you take those EDS foam board, we're going to do EDS, we're going to go cheaper, EDS, we're going to do better. I don't think we do this year, we're fine. So, let's just what we are doing. Let's just what we do using that absolutely. We're going to rest that part of flagging, I'm not flagging. So we're not even 5%. That does on part of the part of the engineer wood siding, it's pretty good. Now we go next year plaster. That would be a big fair amount of time. And again, we'll move on next to that. And wood flagging, that looks interesting. I suspect there's going to be significant supply chain issues with that, and probably some cost issues. However, it looks like we would. How good we're going to get. We're going to go play plaster, which is that's significant. In our interior flagging, so that's going to be rather well. This is an average. We reduce that a little bit just by using some proprietary material from companies that
So,
they'll go down as a
I switched sides once again.
What happened? Oh, you're doing notes?
Yeah.
carbon foot.
I'm just gonna do like skim these.
Yeah, I'm just skimming all of it. I might just go like
Easy
random
board is
video
actually
for like 15-20 minutes. Just
quite a bit higher.
not know too much stuff.
Although it may not have the base profile that does the highway slides.
It's tough.
It's where you get into numbers. Again, some maybe people find and different things, and then finding these plasters. I like line plaster quite a bit. But you see, these line plaster has an actual wall, but a full wall takes up 40 inch. That's quite a higher level. First thing, say line plaster, that's just simple. Line plaster, something to about the plaster you're really high, and yeah, so take that problem out of this. What we do is average is we go ahead and say, okay, where do you find yourselves this time? The best stuff we find. As soon as you start building, it's really easier. That's what okay, so that's pretty good. That's your wall floors. Let's go ahead and say, we figure out how to make that versus the sidewalls. Subflooring with plywood is a kick better than that. Not using floor trusses. I think our floor frame's already good. Well, and okay, that's okay. So our ceilings now, same argument with drywall on the walls. I'm sure the walls don't apply to our ceilings. This is how we do it. And roof. Okay, roof. We're using roof cellulose for good stuff. We did an anti-system and make frame stuff in there, but so we're going to mark. So I think I'll just talk about that too. That's a heavy. Just that. And get into installation and crushes. Again, crushes are good with sideways. But it's only one area. Around so we'll talk about that. I really like everything about the safe last one. That looks okay. Got everything where it needs to be. Good results. Okay, we took this a little bit into the great
Yeah, but
And
seriously,
what do you think
I am very
How much?
pleased with
Basically,
how
you
our
decided
presentation went.
that
And the
we're going to
critiques we got were really
like
good.
that from 4 cavity.
Yeah, I
We
can agree with that.
responded very well. Yeah, like, just very content. Let's see.
Hey,
We got
Wyatt.
kind of getting a rough idea of who's doing what for the next set of deliverables.
Yeah.
You alright?
Yeah. Sorry that I responded like that because you want to do them all this weekend?
No, I'm not. Sorry. I want to get as much done before. I just want to like get as much as I can done before Thanksgiving break because I'll be serving in Portland for my church. I'm gonna be busy like just all 4 days for a bit, and then plus.
Yeah.
And so I just like it's just a little personal thing that I have.
Yeah, but I mean that's all of next week that we have.
Yeah.
Okay. Not this weekend. Not just this weekend.
Yeah, not just for sure. I just like can't lie, Matthew. We need to like we don't need to, but like I feel like there has to be a syndrome or like a word that's like definable. That's like we're in this like constant work loop cycle where if I'm not doing work or feel like I'm not doing anything, you know what I mean? Like, the week after studio and you're just like, oh my goodness,
Yeah.
like I just feel that right now where I'm like it feels like I'm doing absolutely nothing at this very moment.
Okay.
So I just am frantic just to do work because I've just had my brain conditioned just to be producing. So that's why I'm just saying like that. Maybe like it might not even be like just an accurate representation of what I should be doing, but
Yeah.
I just feel like I should do work because it's always what I've just been doing this whole semester.
Yeah.
So yeah, I don't know. Also, dude, we had such I am very excited for the design competitions coming up for like math and geometry. would have been so fun if we had that as like a serious like studio. That would have been crazy. But even then, I'm happy that we have it now. Like just as a quick thing. Yeah. But yeah, so you're just kind of feeling down just because, or not down, but like you're
Just tired. I'm gonna get some sleep tonight.
good. You're good. I think tomorrow, probably like around maybe like between 2 and like 5, I'll talk with Adrian about the presentation, developing it
Could you send me what you currently have?
for the presentation.
Yeah.
Yeah. Are you? Can you access it via? Because I know it's shared, but actually I don't know if it's shared. Let me check.
What am I doing tomorrow?
Good question.
I have class. I wanna chop down some wood for the kendama.
Nice.
As in cut it down to size.
Awesome. Yeah, it shows that you're in it.
Okay, that I can access it then. I know where it is. I didn't know if it was the same one or not.
Oh, okay, gotcha.
Not going to this. Not going to this. I have work. I have class. Charge camera batteries. Make
I think it's
right.
crazy to think about, but there's going to be so many less factors of stress next semester. I think we're going to have probably more stress. It's going to be harder work next semester, but there's going to be less variables.
Explain.
For this semester, we've been caught off guard so many times with Vahid having crazy Dover rules or like.
You're talking about this studio in
Yeah, the
particular.
studio.
Okay, yeah, that makes sense.
Which is like,
I thought you were talking about like just studio in general, and if you're. Never mind. I can't even form my sentences anymore.
really good.
I feel like there's something that's due tomorrow. Why do I feel like that?
I don't know.
Our meeting with Vahid is at 11 a.m. on Sunday.
Seriously?
What?
I have church on Sunday.
At 11 a.m.?
10:30 to 11, yeah. Let's see.
I mean, none of these other times work for you, right?
9, like, yeah, 9 for, like, anything before, like, 10, like, between 9:15 and 10:15.
You could email him about that.
Yeah. I will.
Otherwise, I'm gonna leave it be.
Yeah, for sure.
I'm gonna let you be in charge of that.
Yeah. No. That's good.
Wow, that's a wimpy siren.
We changed our windows all, and we changed our concrete mix and the footings inside of it. That's about it. So that's the kind of comparison we could go through with this redesign phase using just a simple model, just a little box model like that. This would be convenient if you are using simple linear model. Because you've already got this ready to go. And then this tells us that we're starting to see pretty structured, right? We've got pretty nice images right there with pretty we know that the beam is in a great partner. And so one of the things we look at is, look, your partner is great. Even if you're UI, you tend to do a little bit of you've got the opportunity to do on-site remote generation. And it doesn't have opportunities. I mean, and so that's really how much solar you can the more things you have solar you have we can discuss but it's not really any part innovation. Right, so next, part 2 is going to be looking at specific wall sections.
Welcome to the Beam Tutorials. This is a three-part series of tutorials introducing Beam, an online spreadsheet-based application for the Beam Tutorials. This is a three-part series of tutorials introducing Beam, an online spreadsheet-based application for estimating the carbon impact of projects. Beam was developed by the group Builders for Climate. This is a three-part series of tutorials introducing Beam, an online three-part series application for estimating the carbon impact of projects. Beam was developed by the group Builders for Climate Action. This is part 2 of the Beam tutorial. In part 2, we're going to take a look at wall sections and putting 3 different wall section types into Beam to see what the carbon implications are of those different approaches to doing a wall section. So 2 of them are going to be high performance wall sections with different approach to insulation, and one of them is a conventional kind of code minimum wall section. So I've gone ahead and built those in SketchUp. Right here, we can go ahead and shrink down Sapphira. I haven't done a Sapphira analysis. That wouldn't be the right kind of model for that. So here's the wall sections. These are all color-coded out using the tag function in SketchUp so that we can more clearly see the different materials. So if we take a look at the materials here, these wall sections have all been rendered with some earth. So there's your earth. Note that there's a little bit of a slope to the grade, sloping away. This is the code minimum, so we're looking at a crawl space built with a minimum 18-inch crawl space, concrete stem wall, and footing, and measure. Actually, a little further below grade, and we need technically too much. And then over here, these are the 2 higher performance wall sections, and rather than using crawl space, stem wall, and footing, these use a thick slab in a shallow frost-protected foundation system that we talked about a little bit during the first report. The other things you can see are we have insulation in between the flooring system and in the sub-bays. These are built with 16 inch center. These are actually models 16 inch center, but we may specify them as 24s and see what happens if we go 24 or if we go 16 inch center. The green here is sheeting layer on the exterior. The gray here is the drywall. And then here the orange is subfloor, and the green is a hardwood finish floor. The frame system is 2 by 10s with a rim in front, and then we're assuming their siding, which is supported on that side like that, is just nailed right to the sheeting without any arrangement gap. And then this is detail. Chances are this is probably not great detail, but it's also cool in there.
real matter in a and 1 2 by 4, which is going to be the outer wall of the geometric actually. It's not actually a percent wall. Number 8 is it. So, we approach technology well. How does that go to see what happens? Maybe need to change. Here we go. So, we've got 4 we mark, we measure just exactly what we've seen. Well, that's we need to change. 8 feet. It's not much. So, just happen to know that it's a long file. Number 1. We have and look what we have done is it's in the smallest thing. Rebar 14 swing stats, 16 feet. 18 cents foundation. It's not showing current in the angle. And, well, it turns out okay. Good. Probably a little worse than that. Because we used 25 weeks, so you're going to go okay. Make the cheapest possible house again. And then, the frame. That's actually not too on the crawl space. Okay, enough like 1, 2. And, keep that strong slab, but let's go ahead and see if we can use it next. We really use this. Actually, let's go ahead and use it next. Because we are replacing all the much more important things. I'm sure we're going to find out. And we're going to do the same thing with the change that next. That's not really good. I'll go change that. We do any better on a sub slab. I did 9. I mean, foam glass aggregate is not good. Foam glass aggregate, that's going to be all of 7 per inch, so we're going to do estimation. I believe if we use foam glass aggregate, we've got enough of it. And some of this is starting to make this. I think we get rid of the aggregate base brush on there. And then substitute. Okay. Let's fix your footings slabs. Not much we can do project level, all that. I'm going to change the size of everything there. And I set a wall structural ones. That's pretty good actually. Remember, CSR are pretty good. It's application. That's another more in-depth look.
Welcome to the beam. Tutorials. This is a 3-part series of tutorials introducing Beam, an online spreadsheet-based application for estimating the carbon impact of projects. Beam was developed by the group Builders for Climate Action. This is part 3 of the Beam tutorial. Part 3, we're going to be looking at a detailed Beam model of the detached accessory dwelling unit that was covered in one of the lectures. We start off just looking at this fire model here of that, and go to the beam. Cool. We'll go ahead and load this up and populate the detailed information from the beam. So most of these takeoffs are from plans, construction documents that was made for permission to build. And so there's the site plan, floor plans, elevations, spring plans, and the wall section. It's really the wall section that carries most of the detail that's been captured in the beam model of the beam spreadsheet. That's going to be the insulation system, the framing system, and the foundation, and the interior wall edges, ceiling edges, roof system, and that sort of thing. So let's go ahead and get back to the beam here. There we go. And so our continuous footing one has been input here, and that gives us length and height. Actually, this width is not quite 16 because of the way it's favored. So let's change that. Length is correct, and the height of the footing is also correct. This is the interior wall area. There's your slab area, and I think that should be, yeah, that's fine. And then here's your interior wall area there. So actually, foundation slab area should be the entire footprint of the interior. And then this is what we're going to do. This is actually calculated on interior footing. It's not going to matter. We're going to This is part 3. We're going to do for you. Part 3, we're going to be looking at a detailed beam model of the detached accessory dwelling unit that was covered in one of the lectures. We start off just looking at this fire model here, plans, construction documents that were submitted for permission to build. And there's the site plan, floor plans, elevations, framing plans, and the wall section. So it's really the wall section that carries most of the detail that's been captured in the model of the spreadsheet. That's going to be the insulation system, the framing system, and the foundation, and the interior wall edges, ceiling edges, roof system, and that sort of thing. So let's go ahead and get back to beam here. There we go. And so our continuous footings line has been input here, and that gives length and height. Actually, this width is narrow, it's not quite 16, because the way it's favored, so we're going to change that. Length is correct, and the height of the footing is also correct. This is the interior wall area. There's your slab area, and actually that should be, yeah, that's fine. And then here's your interior wall area there. So actually, foundation slab area should be the entire footprint of the building. And then this is what we get. This is actually calculated on interior footage. It's not going to matter whether it's exterior footage. Don't worry about that. Front floor area is the interior floor, finishing etc. And even though the project has a garage, the front area of the ground floor is the garage. The garage is finished with an insulation of the wall system exactly the same level of insulation, the same level of slab, and the same kind of system. So really, it's technically a garage intended in terms of use work. It's built as a so if we go to footing slabs, and this is all as-built stuff here. We had a concrete mix that contained some amount of fly ash. That's what the background does. So we selected that. We used a 4-inch thick slab, and again we selected that choice there. And so steel 14 bars, these bars on footings because of the design of the slab was the bar per se, making the slab, which is all white ash over there. And then sub-slab insulation, and the other is just a okay. And what we got for our exterior walls is give a little bit from an building, which potentially has some benefits. Okay, move on. Windows. We chose a roof frame with a window. That was the engine window. We have a vinyl seam on the outside. It's not actually an option here. This roof frame is about like relative to fill in. And then it's our so 1.2, 1.3, that's the footing. So there will be some ways around that potentially. We can do a perimeter footing and move the same wall that would line up supporting the structural walls, and then do rather than a cord slab for the ground floor, form we can do the earthen floor or one of the options. And then we're going to do that way. That's going to be the next step here with this tutorial. We're going to take this information and here now we're going to come back and see how much water we can do this. And windows with double glazed, again, probably not much room for savings there. Maybe 50 kilos, possibly, not a lot. Exterior wall cladding, this is our interior drywall that goes on the interior of the walls. This is our subslab insulation. So yeah, drop off 3 footings. You have concrete and body. And then here's our biggest inferior to pulling part, or sequestering part. And that's the opposite side of the and then using the interior walls, wooden walls. Alright, so that's what using timber steel. And that brings us to opening part walls, okay, exterior walls. Improvements we make here. So the big change probably with the exterior walls is that now that we're at where lumber prices post-COVID have come back down to where people normal, probably it's either wash or maybe even a little bit cheaper now to build up said walls. That would be the big change. What we do, we're trying to those changes get right here we see white. And this is going to be alter 1 next time. And no, not getting big. And this is alter 2. Not getting big. And this is going to be alter 1 next time. And no, not getting proxy for that. Oh yeah, you got let's just how a little fire. And
Yippee. feels wrong submitting this.
I want to check out what is the
It's, what did you, what?
only Wilson has done these.
Yeah, Wilson is on fire this semester. He keeps responding like before you sometimes. It's a sentence about the lectures and then questions about the lectures, and that's it.
Oh, nice.
Yeah, it's pretty simple.
I hated this lecture. Get me out of this dang masters.
Could say that. You could say that.
Chat, how do I lock it? Matthew. Copy and paste.
I'm just gonna AI this. I wonder what Jason Johnston thinks of this.
What's up?
I wonder what Jason Johnston thinks of this.
Oh, I just loved it.
Bunch of M dashes. Holy cow, give me fewer words. Shorten. 2, 1, 7, 1 to 2, 7. Oh, look away, Wyatt. Not me just copying, pasting AI. I'm not cheating. Okay. Why? It depends. No. That's your own problem. You can find somebody else to do it. Please use the discussion assignment this week for peer-to-peer discussion, understanding the extra content, and initial questions about the final project assignment. If you have time tonight. I said no. And you think nerd's an insult? I wear that title with pride. Get bing bonged.
Okay, finish my notes.
Nice. find it interesting that the Beam tool uses Google Spreadsheets as a base to build from. Makes me wonder
Bang.
why they didn't
Call that boy generational.
make their own, especially when the number of factor
Let's go. I submitted, Matthew.
I also submitted. Did you submit before me?
I submitted 10 seconds ago.
Dang, you might have submitted before me. No! No!
Dude, my questions I literally came up with on the spot of the 5 minutes of the video I watched. And they're pretty bad questions, but it shows that I didn't watch the video.
Yeah. Bing bong.
Let's see.
Ha 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 ha. Another 750 word essay with sources due Sunday. Yippee. I love this so much. And a quiz. And a quiz. Yippee.
For what?
$4.95.
Oh, awesome. Isn't it easy though?
It's easy. It's just like I don't do anything. I learn a little bit. Could actually go get dinner now.
Right.
From the. Oh wait, no, it closes in 20 minutes. Never mind. What am I gonna do for tonight?
OneDrive, open with Adobe Illustrator. Whoa, let's try. I opened it in
Oh.
Adobe Illustrator.
Gotta go see if
You're gonna what?
Connor's in aerospace room or something.
Look good.
I'm just gonna walk over. Alright. Later stream. Bing bong.